Thank you for tuning in to my talk today on changing the way your applications interact with databases. Before we get started, I want to give a big thank you to the HashiCorp team for putting on another successful Hashi Talks. For those that don't know me, my name is Jacob Mammoliti, and I am part of our Cloud and Data team here at PwC Canada. To get started with the talk, I want to present you two memes that sort of focus on the two themes that I want to get across today during the talk. The first one is going to talk about generation of database credentials, and the second one is going to focus on consistency in encrypting data stored at rest. The first meme here shines some light on the dangers of long-lived credentials and the storage of them. Focusing specifically on database credentials, without Vault, you need to determine how you will pass a set of credentials from a database team or a platform team to an application team. Furthermore, you need to determine where those credentials will live. How will the application access them? And finally, what does the rotation ceremony look like? The more questions like this that are asked, the larger the realization that just delivering a set of credentials and rotating them requires multiple hands and consequently eyes on that sensitive information. In numerous occasions, I've seen database credentials stored in config files, environment variables, and in some cases stored directly in the source code in plain text. The second meme here relates to the second theme of this talk, which is consistency in data encryption. I've worked with many organizations in the past that have struggled to find common ground when it comes to encrypting data across their portfolio of applications. It turns out that without providing a standard interface to encrypt data, you introduce room for siloed decisions on how that data should be encrypted. And the reality is, many developers are not security experts, so at best, you get this inconsistency on how they handle data. Looking at this meme, we see that one developer is using encryption, another is using some hashing technique, some teams are just using base 64 encoding, and one developer thinks everything is the same. Given that, I tend to promote that as a platform or a security team, your job should be to enable these application teams with a single interface that you control to encrypt data. By doing this, you remove any uncertainties on what your stance is on data encryption. This becomes exponentially easier during times of technical audit. You now have your standards set by a single team that control the type of encryption you're using, the rotation schedule, and audit logs of when the application interacted with those encryption keys. So again, just a quick introduction to myself. Like I said, my name is Jacob Mammoliti. I am part of the Cloud and Data practice here at PwC Canada, and I'm based out of Toronto. And most of my job is really focused on enabling clients and helping them on their cloud journey. I tend to focus on most tooling under the CNCF ecosystem, so mostly focus on containers, CI/CD pipelines, and everything around that, as well as focusing on all things HashiCorp. So focus on Terraform, Vault, Console, and all the other tools that HashiCorp provides. In addition, I also manage and host the HashiCorp user group here in Toronto, so if you're watching this and are from Toronto, make sure you check up our meetup to check out when the next user group is. So to get started, I want to sort of talk about how does Vault fit in the picture when we're talking about database credentials. So a couple of slides back, we talked about having this database team or some team giving the application team credentials that they've provisioned, and we pass that along, and now we start to figure out or ask questions about what does the rotation look like, how are those credentials being passed, and how are they being stored. So when we think about that, in addition, maybe the app team generated those credentials. Whatever the case may be, the role associated with those credentials and the credentials themselves had to be manually created and injected into the application some way. In the event those credentials ever got leaked, they would be valid until they are manually revoked, and anybody could use them. There is no time to live, and there's no additional guardrails to prevent any sort of misuse. So what's the solution for this? Well, Vault provides a secrets engine that can generate dynamic, on-the-fly credentials for your databases. These credentials can be provisioned by your application right when it needs it, and Vault then takes on the responsibility to broker those credentials while also ensuring that they are revoked when they're no longer needed. Now, when we talk about support, Vault supports many databases such as Postgres, Microsoft SQL, MySQL, Oracle database, and many more. You can check out the HashiCorp website to see all the supported databases. But I found that those ones I just mentioned tend to be the most use cases that I see when working with organizations. So by leveraging Vault to broker those credentials, we now have talking about going back to that centralized tool, we now have that centralized tool responsible for maintaining and distributing credentials that have a TTL, or a time to live. Additionally, we have full control of the audit trail of when those credentials were generated and where they were used. So if we look at the Vault audit logs, again, like I said, we can see when did an application actually generate those credentials, and we can also see stuff like source IP and all that sort of stuff of when it was actually used to have a detailed audit log, all central to Vault. So now, if we look at the application on the right, this kind of breaks down the workflow of when an application needs to interact with Vault to go ahead and authenticate to a database. So kind of going through this one by one, we see step one is that the application requests database credentials. So in this case, the application is going to go to Vault and say, hey, I need database credentials. So what we do is we'll specify what Vault calls a role, and we'll show this in the demo, and that role contains information about which database to generate credentials for, the permissions to assign the database role, and the length of time that these credentials are valid. Vault will then go ahead and communicate with the database to generate those credentials. So for example, in Postgres, it will run a series of customizable SQL statements. The output back from that is a dynamic username and password. This can also be configured as well, just to use a static username and generate a dynamic password as well. Regardless, once Vault receives those credentials, it will then return them back to Vault, which will then eventually be returned back to the application. Finally, the application can now use those credentials to authenticate to the database and proceed with the task. In that whole process, notice that the application team never needed to handle a set of credentials. They never saw them. As you'll see when we flip over to the demo application after a few slides, we'll see that the developers just need to write the code to interact with the Vault, with HashiCorp Vault and the database. The brokering of credentials and the handling all of it is all handled by Vault. So we now understand, okay, we know how to authenticate to databases with short-lived credentials, but now let's talk about the sort of the second theme of this talk, which is standardizing on data encryption. In the first slide, we sort of talked about the silos and inconsistencies that come up where there isn't a clear standardization of how to encrypt data across applications. One team moves forward with AES 256 encryption, while another team uses an MD5 hash function. Regardless of what they use, there isn't a standard, and that's where the problem lies. But being able to centrally control what kind of encryption keys are available, the rotation schedule, and have a view of the detailed audit log is a pattern that all organizations must strive towards. So coming back of where Vault fits into this picture is Vault can sort of be that sort of consistent API, if you will, to encrypt and decrypt data via its two secrets engines. And the first one is Transit, and the second one is Transform. So we'll talk about Transit first, and then we'll move into Transform, just because they are two separate offerings. So Transit is a secret engine which provides the ability to create encryption keys of many different types, right? So we can use AES 256, RSA, ECDSA, and many more. Again, if you want to see a full list, you can just visit the HashiCorp website to see that. Now, going back to how this is set up, platform owners of Vault make these keys available to consumers to encrypt and decrypt data that is sent to it. Vault doesn't store this data, it merely provides just an API to encrypt and decrypt that data. It's more just a tool to actually just do that encryption. It's up to you to then take back the ciphertext and do something with it. So Transit also supports convergent encryption, in which plaintext and context generate the same ciphertext as well. Now, a sample use case of this is if I want to check if an email address has already been used when someone's signing up to my website. Instead of reaching out to my database, decrypting all of the emails to see if one matches, I can simply take in the email that the new user's provided, I can encrypt it, and then just compare the two ciphertexts. If they match, then we obviously know that that email is already used. So we'll say that our email has been used, you must use something else. Now, like I mentioned, in addition to Transit, there's another secrets engine called Transform. Now, Transform is an enterprise feature, and it performs a bit of a different operation than Transit in that instead of sort of quote-unquote encrypting data, it actually transforms data given the input. Now, when we talk about Transform, there's really three capabilities that this sort of does. The first one is FPE, Format Preserving Encryption, where I'll give you the easiest way to describe this is an example of a credit card. So let's assume that my database expects a credit card or expects data in a column to be a specific shape or a specific type. I can use FPE, Format Preserving Encryption, to, sure, I can encrypt those credit card numbers, but the format is the exact same, so I don't have to make any schema changes on my database. The second capability is masking. Now this is really just for replacing sensitive data with masking of the characters. And then finally, we have tokenization, which replaces sensitive information with mathematically unrelated tokens. Now, kind of just tying back to the whole grand picture of what are the benefits of using a tool like Vault, is really the biggest thing is it comes down to central control, really sort of on two aspects. One is from an audit and logging perspective, where I can guarantee that everything is now central through Vault. If you want to encrypt data, I'm making the standard that everyone has to interact with Vault, so that way I can see a full audit log of when applications are using it and how they're using it. Now, the other benefit here is that by standardizing on a tool like Vault, this works across anywhere that my applications live, whether they live in GCP, AWS, Azure, on-prem, some other cloud provider. HashiCorp Vault can still be that central tool no matter where my applications are deployed. Now, finally, I just want to spend a slide before we go into the actual demo, is I just want to spend some time talking about the demo environment that we're about to see and sort of paint a picture of what it's going to look like. So I've created an application that effectively just interacts with Vault to take in an email address and a name. It's then going to go ahead and interact with Vault, and specifically the transit secrets engine, to go ahead and encrypt the email before storing it in the database. Now, going back to when we were talking about dynamic database credentials, and what I'll show in the source code is that my application is also written to reach out to Vault to also first grab database credentials. It then goes ahead and encrypts the data, and then finally stores that encrypted data into the database. So kind of looking at what this diagram looks like here, we can see that in GCP, we have my application, which is going to be running in Cloud Run. And really, like I said, the two main things that it's doing is encrypting and decrypting data, and it's also requesting those short-lived database credentials. Now, in the landscape of things here, I can have my Cloud SQL, or I can have my SQL servers or any databases stored in GCP via Cloud SQL or something like AlloyDB, but I could also have my application interact with databases that are on-prem. And the idea here is that they're able to interact the same way because I'm using Vault as sort of the mechanism to generate those credentials, while also using Vault to encrypt my data and decrypt it whenever I need it. So the workflow here, like I mentioned, just sort of to recap, is that my application running in Cloud Run reaches out to Vault to get the database credentials. It then goes ahead and reads in the user input from the form. It encrypts the email, and then eventually stores that data into the database. And what we'll see here is all the way I've written the application. It's very a demo application, so it kind of exposes a lot of information, but this is more just for demo purposes, just to kind of show what's kind of happening behind the scenes. So we'll show what the data looks like when it's stored encrypted by Vault into the database. So with that, let's jump over to the demo. So now let's spend some time looking at the code that's going to make up our application. Like I mentioned, the idea with this app is that it's a Flask application, and I'll just flip over and show it. It's a simple Flask application that allows me to input a name and an email address. I can then submit that, which is going to go do a few things that we talked about in the slides to actually go ahead and encrypt the data and store it in the database. And then there's a view records, which we'll look at shortly, to just go ahead and have a peek into the database once that data is stored. So let's spend some time looking at the actual code itself. So like I mentioned, the idea here is that we want to make sure that our application teams are well equipped to go ahead and interact with interfaces, let's call them, to effectively do two things. One is have a way to reach out to Vault and generate dynamic database credentials, while the second is being able to have a consistent API across all of our apps to encrypt and decrypt data. So with that, this is what my Flask application looks like. And the first thing that I'll kind of focus on is these two lines right here, where we're calling a Vault class, and then we're doing a Vault Connect. So this would be sort of standard if I were a sort of overall application architect for multiple apps, this is sort of the first things that I've established, that in order to connect to databases and to encrypt data, you're going to want to call on this Vault class here. So let's go ahead and look at it and see what actually is going on. So what we've done here is we've defined a Vault class, and what it's done is it's using the HVAC library to go ahead and interact and interface with our HashiCorp Vault instance. In this case, it's just Vault running in HCP. So what we're doing here is, and I've made this very specific for the demo, and I'll sort of talk a little bit about that as well, but what we've sort of done is we have an initialization method in the class that allows me to specify a host, a Vault host, a namespace, and a role ID and a secret ID. Now, the way the application is connecting to Vault is via app role. And the reason for this really just is for demo purposes here, is that because my HashiCorp Vault is running in HCP, in order to use the Google Cloud authentication method, I would need to generate a service account key, which this environment that I'm in doesn't allow me to do. So in that case, just in order for the app to authenticate to Vault, I'm using app role. But it would be very common if an application was running in something in GCP to actually just use the GCP auth method. But anyways, going kind of back, focusing on this, really the main thing is that we're allowing our host, a namespace, role ID, and secret ID. We then saw that sort of connect method, and really what this is doing is this is just allowing us to connect to HashiCorp Vault and make sure that this app can effectively do that. So what we do is we pass in our role ID and secret ID to go ahead and do that. And assuming all is good, we try to do an authentication, and if all is good, we're going to get back a successfully authenticated with Vault. Now, let's spend some time looking at sort of some of the other methods that are available as well. So what we're going to use later on is generating database credentials. And we're going to need this really for storing our data eventually. So what we have here is that we're going to go ahead and reach out to our database secrets engine to go ahead and effectively create a dynamic username and password for us. So that's gone ahead and is effectively just done here. We go ahead and as a app team, I say I need a database name, database role, and I need to know the mount point of where it exists in HashiCorp Vault. So this would be something that's going to be provided to you from the Vault platform team to the application when they want to get onboarded. You're going to get back a role and a mount point. And we talked about roles previously in the slides, but sort of just to recap, the role, and I can actually just show what it looks like. Again, this is just for demo purposes. Is I can go ahead and look at the role, and this is where the role exists. So I'm doing this with Terraform, just two reasons. One, it's very recommended in terms of maintaining your day 2 operations of Vault, but also just so I can spin this demo up and down very easily. But focusing on sort of what this looks like, the idea would be that each application that gets onboarded to Vault has its own role. And in that role, we go ahead, and this talks about the creation statements. Each time this role is run, we go ahead and run these creation statements to create a role for us. Now, mind you, especially if anyone's familiar with SQL, this is by no means recommended practices where we're creating a table in this creation statement, if it not exists. We're also granting the user a high level of permissions. Again, this is merely just for demo purposes, just to spin this up and down. But the idea here is that you're really just going to have a create role, and then you can customize this creation statement however you choose. It just in this case for a demo, I've kind of given it some high-level permissions and doing some unordinary things around creating a table. So just kind of want to make sure that that's clear. But heading back over to the actual code, that kind of explains what's sort of happening here. So when I actually go ahead and request these generation of credentials, Vault is actually going to act on my behalf to go ahead and run those SQL statements to get back a username and a password. We're now getting into where transit comes into play, right? So very similar to, or somewhat similar to how we did the database stuff, we're now going to go ahead and need to define two methods. One is going to be to encrypt data, and then you're going to see after one is to decrypt data. And how this is going to work is that what this method takes in is it takes in the plain text, it takes in the context if we chose that we wanted to do any convergent encryption. We then specify the encryption, the name of the encryption key that we want to use, and I'll talk about that in a second. Finally, like we did with the database, we need to specify a mount point in Vault. This is where the secrets engine is mounted. Now, kind of similar to what we saw earlier, we're going to go ahead and take that plain text. We're going to base 64 encode it because that's how we're going to send it to Vault to do its encryption. We then go ahead and interact with the encrypt data part of the HVAC library to go ahead and actually encrypt the data for us. And if all works out well, we should get back the ciphertext. Now, let's go ahead and have a look at what the how we set up the transit secrets engine. So this one's pretty simple. We essentially just did a few things here. We enabled this transit secrets engine and mounted it at the transit endpoint. We then go ahead and create an AES 256 GCM 96 key. Now, what this does is this specifies the name of the key and then the type. So kind of going back to what I was talking about earlier, transit supports multiple types of encryption keys. This one that we're creating is an AES 256. So we go ahead and create that. And then we also create a convergent key in case we wanted to use that down the line too. But really, like I said, the main point here is that as an application team, as a platform team, I'm saying to my application teams, use this encryption key name and I will provide them the name that they can use. So let's go back over to Vault. We go ahead and set that up for the encryption for the encrypt data method, and then the decrypt data method. It looks pretty similar, except we're just doing it in reverse, right? So instead of taking in plain text, we're now taking in ciphertext. We take into context if needed. We take in the decryption key, which is really just that it's that key name, and then we specify a mount point again, and then we just do what we did above, but in reverse, obviously, to get back plain text. So if we go back over now to our main application, to our main Flask application, the other thing that we sort of highlight, and like I mentioned here, is the name of the encryption key as well as the database role. Now again, this would be me as the platform team providing this to my application team so that they can set this up, because those are required attributes when they call on the specific methods to encrypt data and to also connect to the database. So now let's get into how this application actually works, right? So we see that when the application comes up, we do an initial connection to Vault to just validate that the application can authenticate and get back a token, which it's going to use later to do subsequent API calls. We then go ahead and, if it's a post method, so if we're actually submitting data, what's going to happen is we're going to go ahead and first reach out to Vault and encrypt the email address, right? Just for this purposes, we don't care too much about the name we want to encrypt. It's really just the email that we want to encrypt. So we go ahead and do that, and we get back our return ciphertext. The next thing we do is we run this PSQL DB connect, the DB connect method. Now let's go over and spend some time in the Postgres class to understand what's sort of effectively happening here. In this case, it's very similar in that we're just defining a sort of interface for application teams to use to interact with Postgres databases. So this is very similar. This would work pretty much the same even if we weren't using Vault. The whole idea is that me as an application team to my database really doesn't care that we're using dynamic credentials, and it shouldn't change any sort of workflow. The workflow is the exact same. The only difference is that as an application, I'm just making an extra step to connect to Vault. But in terms of my database knowing, it has no idea that I'm using short-lived credentials. It's up to Vault to go ahead and issue those credentials and revoke them. But as far as the application's interface for Postgres goes, this stays the exact same. So if you go through this code, we'll actually see that there's no real relation or connection to Vault. It's merely just taking in standard arguments. For example, like the host, the name of the database we want to connect to, the username, the password, and that's about it. From there, we run that connect method, which we just saw, and effectively all we're doing here is just connecting to the database and just making sure that we can provide a successful connection. We then define a few other methods here that we're not really using so much in this application, but we have a create table if we wanted to create the table. And the one that we're kind of focused on are these two methods here. So the first one is insert data. Now, this again is very standard. We just pass in a table. We're going to pass in the series of columns of how we want to submit this data, and then the values that we should provide when we're creating a new row in that table. We create the SQL statement, again, all very standard procedure when interacting with a database. On the retrieve, it's sort of the same thing. We're passing in the table name and the column that we want to retrieve from our database. And then additionally here, we're also providing a value if we want to include or we want to retrieve data for a specific user, for example. Again, the main idea here is that there's no real specifics to Vault here. The idea is that we're just standardized, we're just regularly connecting to a database like we would have, even if we weren't using Vault. So let's go back to the app. We now create our DB Connect. We then run our insert data method, which we talked about, to insert the users into the users table, or inserting the name, the email address, and then the values are the plain text name, and then we're inserting the ciphertext, which we generated from running against the Vault encrypt data method. The other option here is talking about the records. So this is what I showed earlier, where what this is going to essentially do is this is going to connect to our database again with a new set of dynamic credentials, and then it's going to go ahead and run the retrieve data method to retrieve all of the data for the users in the users table. Now, the one thing I want to highlight is just around this DB Connect, which we just kind of show but didn't actually describe what it's actually doing. This is where the function is defined. So what we're doing is we're running against Vault to generate those dynamic database credentials. And in our case here, this is where it can start to be customized, is that you can see that we're running this pretty often. So in this case, we want those credentials to be pretty short when it comes to time to live. So that could be for 5 seconds, it could be for 5 minutes, it could be for an hour, whatever. It really just depends on how your application runs, right? It depends on how many times is it reaching out to a database to go do a thing. Is it connecting to a database like it is here, where if it's hitting the root endpoint, it's connecting. If it's hitting the records, it's doing another one. Or is it in some cases where the DB Connect is actually established when the application comes online? Those TTLs really just come down to how your application is structured. I would recommend that doing more short burst connections with shorter time to live is a better procedure. However, I understand there's a lot of implications when it comes to refactoring applications to do that. Just using Vault at all when it comes to database, dynamic database credentials is a huge step. So kind of just recapping that, we generate the database credentials. We then go ahead and establish our Postgres connect with those new credentials we just retrieved. We do a connect, and then we get back the PSQL cursor, which we're going to use to actually go insert data and retrieve it. Okay, so with that, let's flip over to the actual application and see how this works. So I'm going to input my name, and then I'll input an email at test.com and hit submit. And we can see that the data inserted successfully into the users table. So if I go over to view records, and this is really just a sneak inside of what the database looks like, so I don't have to just go ahead and interact with the database directly. This is really just doing a select all like we saw. So we see that we got back the name, and we're also getting back the email, but it's encrypted. And this is what it looks like when we encrypt data with transit. We see that we have Vault, which is just specifying this is encrypted with Vault. We then see we have V1. Now, what this V1 represents is how many times, or the version of the encryption key. So let's say in a month that we want to rotate our encryption key, we can go ahead and rotate that on the Vault side, and this will increment by 1 each time we rotate. So if I rotated and encrypted again, we'll now see V2, V3, V4, and so on and so forth. And then finally, after the second colon, we see our encrypted data here. So that's essentially what it looks like. So we can just do it one more time. View records, and again we see test, and then we see a new set of ciphertext. So again, this essentially just shows what it looks like when we want to have our application interact with Vault on 2 different forms. One is to dynamically generate credentials to authenticate to our databases, but then the second is using Vault as the standard encryption tool across all of our databases. Now, where this really shines, and we kind of just focus on it on one part of the demo, is with Postgres, right? So of course, this works great with Postgres, and we see that, but really where Vault kind of shines is that if we can establish that Vault is the encryption tool for all of our types of databases, whether it's Postgres, whether it's Microsoft SQL, MySQL, MongoDB, whatever the database is, we want to make sure, we want to strive to having a single tool that's responsible for encrypting our data. It's a single API. What this allows us to do is this allows us to leverage reusable code like this Vault class here multiple times, right? We can extend this to now be able to support Postgres. We can now extend this, MySQL or Microsoft SQL. But the idea is that all developers across different applications are interacting with the same sort of class, and it's the same reusable code. So that way, no matter which application team I ask, I can guarantee that they're using the same method of encryption than app A is, and app B is, and app C is. So the idea here with Vault across generating dynamic database credentials and also encrypting data is just that level of consistency, both from an application developer standpoint, but then like also mentioned on the audit side. So we have a clear method of here's how we are encrypting data, here's how we're generating database credentials. So with that, that's kind of all I wanted to cover with this talk today. I hope you found it super informative, and I really appreciate everybody tuning into this talk. Thanks again, HashiCorp, for setting this up and giving me the opportunity to speak here. If you have any questions, please ask them in the comments below, or feel free to reach out to me. The one thing I want to mention too is that this repository is available on my GitHub. My GitHub is Jacob Mammoliti, and the repository is called HashiTalks 2024. So if you want to check out all of this code, you can do that there. Again, thank you so much, everyone, for tuning in.